other aspects of the life cycle. And snook are an interesting fish. You can look at one up there that's 2 days old. I'm sure everybody recognizes that one, right? And so there's a 2-day-old snook, and there's one that's about a month and a half. They take a long time to grow. At a month and a half, they're only about this big. I currently have thousands of little babies. They are about 2 millimeters in size and eating rotifers in the laboratory. So here's the eggs, then you get these larvae. After about 3 months, you might end up with a fish that's about this size. And Ken wants those fish to be even bigger than that. So we have lots of areas that we need to focus on in the hatchery to make it successful. So in snook larval rearing, the focus has been on trying to provide the right food in order to increase survival in the early stages. And so every aspect of this animal's life cycle is a challenge. They're a unique fish. They all start off as males, and then a certain percentage will switch and become females when they get to be about 2.5, 3 years of age. And so we have this difference that we have to deal with in captivity, where we're looking at fish that have the sex change issue. We also have fish that have extremely small larvae, less than a millimeter in size when they hatch out, requiring large volumes of live food. And so what we've been doing is trying to identify the best live food that can be produced in numbers. And so we've been focused on that and identified what's needed and what we can do in order to make some successes in that area. But the other issue is that they're very delicate. If you even look at the tank sideways, you can end up with them keeling over. Definitely if you stir them around too much, you can have a major impact on them. So our focus has been for the last 2 years on identifying the optimal conditions for them. And we've identified the amount of aeration, the amount of current, and then in the recent trial we just completed, we actually changed our lighting regime, and we're now providing light for 24 hours a day for the first 10 days of life. And so that's another success that's improving our production as we move through the cycle. The other research focuses are on trying to reduce the amount of time that you have to feed them live food. And a lot of that, you know, we're trying to recreate nature in the lab, but also do it and not break the bank. And so there's some challenges with producing live food, because to produce a live food, you got to both make the fish, make the live food, make the food to feed the live food. You got this whole life cycle going, and every bit of that costs money. And so we've been working on trying to reduce live food, identify when we can wean them, add probiotics to the diets. Those are the kinds of areas we're working in larval rearing. And then the next area is to get those fingerlings, because I only could get them up to about somewhere between here and here, depending on the study that is being done, or the best size for release in a particular habitat. And that varies depending on where you're releasing them, as Ken told you a few minutes ago. So we have to do this fingerling production, and our focus has been on reducing cannibalism. There's the other big problem. First we got to get them to spawn, then we got to get them to eat, then we've got to get them not to eat each other. And so that's our focus for the last couple of years. Using traditional strategies that are used to make that work do not work with snook. If we did that, pardon me?
That picture in the upper right there.
Yeah, there's one right there. There's a fish eating another fish that's the same size as him. They'll kill themselves eating their brothers. And so what we've been doing is working on trying to reduce deformities, because when you use these normal strategies for reducing cannibalism, you in fact get deformities. And then the other area is on conditioning fish.